You know, the railway is an industry that's been around for centuries. But a very 21st century tool, data analytics, is completely changing the game in ways you might not expect. So let's dive into how it all works. To really get this revolution, you first have to understand the challenge at the heart of the modern rail industry. And it all kicks off with a massive, just overwhelming flood of data. So, when you think about a train, you're probably thinking about its schedule, maybe its speed. But what if every single part, every little vibration, every shift in temperature was telling a story? What can all of that data really tell us about a train's health and what's coming down the track? That's the big question here. And the answer is a whole lot. Modern trains are basically gold mines of information. I mean, we're talking sensor readings, maintenance logs, performance metrics, just a constant, nonstop stream of data from every piece of the fleet. The problem was never a lack of data. It's that railways were often rich in data, but pretty poor in actual usable insights. And that brings us to the core mission. The whole goal, as this quote puts it perfectly, is to transform your maintenance data into actionable intelligence. It's all about taking that raw noise and turning it into a crystal clear signal that an engineer can use to make smarter, faster decisions. Okay, so how do you do that? How do you get from a bunch of raw numbers to these brilliant insights? Well, it's not some single magic leap. It's more like a structured climb. The best way to think about it is a journey up a ladder of intelligence. Each step you take moves you from just looking at what happened in the past to powerfully predicting and even shaping what happens next. And this ladder has 4 key levels or rungs of intelligence. You start with descriptive, you move up to diagnostic, then on to predictive, and finally you reach the top, prescriptive analysis. Each one answers a more complex question than the one before it. Let's break them down. So the very first step is descriptive analysis. This is the foundation for everything else. It's basically looking in the rearview mirror and answering one simple question: what happened? This is where you organize all that data to see things like, what were our most common maintenance issues? Or what was the average downtime for the specific repair? It gives you a really clear picture of the past. But just knowing what happened isn't really enough, right? The next big question is why. And that's where diagnostic analysis comes in. This is where you become a kind of data detective. You dig into the patterns to find the root cause, like figuring out why a certain part fails way more often in the winter. You're shifting from just observing to actually understanding. Now, this is where it gets really interesting, because we start looking forward. Predictive analysis uses all that history to forecast what's likely to happen next. It answers the question, what will happen? This is where you can say something like, based on the data, this axle bearing has an 80% chance of failing in the next 500 miles. For maintenance, this is an absolute game changer. And finally, we get to the very top of the ladder, prescriptive analysis. This is the most powerful level of all, because it doesn't just tell you what's going to happen. It tells you what you should do about it. It actually recommends the best course of action. So should you replace that part right now, or is it more cost-effective to wait until the next scheduled service? It gives you those clear, optimized answers. Okay, so that's all the theory. But how does this data ladder actually translate into real-world tools that engineers and managers can use to keep the trains running smoothly? Well, what you're seeing here is a fundamental shift in mindset. See, traditional reporting is all reactive. It's about analyzing failures after they've already happened, always asking, what went wrong? Smart analytics, on the other hand, is proactive. It asks, what will go wrong, and how do we stop it before it ever does? And this is all made real through a whole suite of powerful tools. We're talking about custom dashboards that give you a live health check of your entire fleet, really sophisticated models that predict failures, and even automated alerts that flag potential problems in real time. This is about turning those high-level insights into practical, everyday advantages. And here's what's so crucial to understand. This isn't just about doing the same old thing a little bit faster. This kind of expert analysis helps engineers find what they call the unknown unknowns, those hidden patterns and system-wide issues that old-school reporting would just completely miss. It lets them fix problems they didn't even know they had. So where's all this heading? I mean, what's the ultimate goal of putting all this data on the tracks? Ultimately, it really boils down to these 3 pillars. When you manage maintenance proactively, you enhance efficiency because your trains spend way more time in service and less time in the workshop. You cut costs by avoiding those huge catastrophic failures and optimizing repairs. And most importantly, you improve safety and reliability, which is the absolute bedrock of any public transport system. And look, this isn't just some theory. This exact approach to data-driven maintenance was actually recognized by the ERCI, that's the European Railway Clusters Initiative, as an Innovation Award winner. It's real-world proof of just how impactful this shift is in the industry right now. So we'll leave you with this thought. We've just seen how climbing the analytics ladder can turn a 200-year-old industry into a model of proactive, data-driven efficiency. If this level of intelligence can guide an entire railway network, well, what industry is next? Thanks for joining us.